Hi, in this video we will be covering factored form in our quadratic function graphic organizer. You should be adding on to the same graphic organizer, whether it be in your notebook or on paper if you were able to print it. We've already covered standard form, vertex form, and now we're doing factored form. And I will be working out in this video 3 of the problems from Delta Math on this sheet. So by the time we finish this small section, I'll have covered 3 of these problems. All right, so remember that standard form is in the form y equals ax squared plus bx plus c. This is the form most familiar to us. But the big significant things you need to understand are that if our a is positive, it'll open up, our parabola will open up. If a is negative, it'll open down, and our y-intercept is always the constant term, okay? So again, y-intercept equals the constant term. Next, for vertex form, we have y equals a times the quantity x minus h squared plus k, where, again, the a value still serves the same function as it does in standard. And we also have the vertex, which we find by switching the sign of this number and keeping the sign of the constant at the end, okay? So switch keep, or opposite keep. And then we did some examples. The next form we're going to be working on is factored form. Well, we've already learned to factor. So if we see something that is in factored form, then we're most often going to see 2 sets of parentheses. We do have an a value. Sometimes if you don't see that number, it means it's an understood one. But I just want to go over the notation. So this is y equals a times the quantity x minus, I'm going to use z sub 1 and x minus z sub 2, z for zeros. So remember, we've already talked about this language of zeros or roots or x-intercepts. In fact, sometimes, depending on what you look up on the internet, you might see it written with r's instead of z's to represent roots. So r for roots. And of course, they can use anything they want. Sometimes I've seen it as p and q, or x sub 1 and x sub 2. So I generally, just because students have a hard time, sometimes it's hard to differentiate between a z and a 2, I tend to stick with this form more than any other, okay? So what knowledge can we gain? What feature can we gain by looking at a quadratic equation or function in factored form? We can get the zeros or the roots. So what this means, though, is that we have a simple process of setting the factors equal to 0. So I'm just going to go ahead and pull numbers 1, 2, and 9 straight from your Delta Math assignment. So this is number 1, and it'll look like this: determine the x-intercepts. So remember that roots, zeros, x-intercepts, they're all synonymous. So I'm just adding x-intercepts on my notes. And I know it's written as the quantity x minus 4 times the quantity x minus 3 equals y. But more often than not, in fact, almost always, you're usually going to see a y equals first, okay? And this is super helpful because where else do we use things in y equals form? If we go to our Calculate 84 app, we use y equals right here. So we can see very important features by putting it in y equals form, okay? So what do we do in order to find the x-intercepts? So these are really, you got 2 instructions. Set factors equal to 0, and then solve both equations for x. And that's really it. Set your factors equal to 0 and solve both equations for x. So I'm going to set x minus 4 equal to 0, and I'm going to set x minus 3 equal to 0. So that's step 1, and then step 2, I'm going to solve. Well, you can probably do that in your head. What number minus 4 equals 0? 4. But algebraically, by doing inverse operations and adding 4 to both sides, we can see that it is 4. So sometimes when you enter in your answers into Delta Math. They might ask it a different way. Luckily, these are multiple choice. So let's look at all these. Notice we have a bunch of ordered pairs, and some of them have 0 as the second number, and some of them have 0 as the first number. So how do we know which it is? So let's talk about that. So if I graph this parabola, what are some things I know about it? I know that because I have an understood 1 in front, that my A is equal to a positive 1. Well, that means my parabola is going to open up. My roots are where it hits the x-axis. So I have it hit at 3, and I have it hit at 4. Well, if it opens up, it's going to look something like that. Okay? So what are these ordered pairs? Well, if this is where it hits the x-axis, it would make sense that the x is the number here 4. Oops, that's 3. I totally wrote that backward. That's 3, 0. And this point here would be 4, 0. Okay? So make sure you put your x-intercepts in for the first coordinate in your order pairs. So we would choose 4, 0 and 3, 0. One of the things I want you to also notice is that, guys, remember in vertex form how we switched what came out of parentheses? That's exactly what you can do here. So what's the opposite of minus 4? Positive 4. What's the opposite of negative 3? Positive 3. So it's almost like vertex form, except now we switch. We switch the sign of both. Okay? So again, same exact steps. To find the x-intercept, set y equal to 0, solve both the equations, and organize them in XY format. So 4, 0 and 3, 0. Okay? And next I'm going to move on to 2. And I'm also going to add this to our box, but I'm going to start off with y equals just because it's my preference. And remember, we're going to do the exact same steps. But what I want you to notice is that we can switch signs. However, it's not that easy for this. Okay? So here, as long as there's a positive x, if I see x minus 2, then what minus 2 equals 0? A positive 2. So I want my x to be a positive 2. So it's either that one. Well, guess what? It's the only one where x is positive 2. So let's go back and explain why, though. Again, if I set these factors equal to 0, I would first subtract 3. I would be left with negative understood 1x equals negative 3. And then I would divide both sides by a negative 1. So that gives me the order pair 3, 0. And of course here, this is so easy we can really just do it in our head. So that would be the order pair 2, 0. So 3, 0 and 2, 0. And last, I just thought we'd take a look at number 9. So if I set each of these equal to 0, you can probably already think the opposite of what plus 1 equals 0. The opposite of what plus 1 equals 0. Or same here, opposite of what number plus 2 equals 0. But I am going to add this in. I'm going to write small and add it in on our graphic organizer. So we'll have one of these where the signs are different, where our x's are negative actually. And if I set this equal to 0 and solve, dividing both by a negative 1, I'm going to end up with 1. So I have the order pair 1, 0. And then if I subtract 2 from both sides and divide by this negative 1, I get 2, which is 2, 0. So 1, 0 and 2, 0 would be our solutions. Remember that when you solve again for x, your x coordinate in these order pairs should be the x values, not the y. Y will always be 0. And why is that? Because everywhere a graph hits the x-axis, y is 0. Remember, this is y 0, 1, 2, 3, etc., negative 1, negative 2. Right here, my y is 0. So that's why my y coordinate always has to be 0. I'm just going to add 1 on here because we should understand this in factored form. If I give you 1, that looks a little different. Let's say I give you 2x plus 3, y equals the quantity 2x plus 3 times the quantity 5x minus 1. Well, is it really any different? No, but we can't just look at it and switch it and call that -3 and +1. And the reason is when we set our factors equal to 0, it's actually a 2-step equation. So what's 0 minus 3? -3. That would be -3/2. Therefore, -3/2, 0. If I add 1 to both sides and then divide by 5, I get 1/5, so I have the order pair 1/5, 0. Now, if I were to look at where that crosses on the x-axis, like say we type this in a Desmos and look at it, that would be at -1.5, and that would be at 0.2. But that's traditionally how we write our answers. Just wanted you to have one that's not like the one in Desmos, but understand that when you have a coefficient other than 1 or a -1, that is still just a normal 2-step equation process that you would use to solve. Okay? So I'm just going to raise this up in case anybody needs to take a screenshot and copy that down, or to take a picture. Get it to focus. So your job, all this graphic organizer, you want to have this out when you take your quiz and when you take your test, okay? If you need any help, join us on Zoom. There is a separate video, by the way, for how to do 10 through 17, because these are based on graphs. All right.